The Apache web server kickstarted the growth of the World Wide Web, back when people called it that. Today, it powers nearly 40% of all active websites. Meet its architect, Brian Behlendorf. He's now focusing on an issue brought on by the mainstream internet.
There are a lot of people saying there's more to this than just spending money and moving money around. Could we use this as a way to reestablish how trust works on the internet and try to decentralize a lot of things that today it led to being centralized?
As the original technologist for the Burning Man Festival, it's no surprise that Brian wants to keep power in the hands of everyday people.
The blockchain industry has grown, and at Hyperledger we realized pretty early we needed to be a home for a lot of different ways to build a blockchain.
As executive director of the Linux Hyperledger project, he's working to fulfill the promise of blockchain technology beyond the coin.
For many of us who've been on the internet for a long time, there has been this creeping sense from about 2005 onwards that the increasing adoption of the internet and digital processes by businesses, by society, by government was going to lead to more centralization rather than decentralization, right? And that we kind of, as technologists, inadvertently made it really easy to build 800-pound gorillas at the center of markets, at the center of communication systems.
Could I please ask you all to stand up? Stand up, please. I think this man deserves a standing ovation, and with your help, we will give him one. Please welcome to the stage to talk about building an open source community for enterprise blockchain, Mr. Brian Behlendorf. Welcome, Brian.
Wow, with a build-up like that, I'm not sure I can deliver, but let me give it a try. And first, I just want to emphasize, I was there at the beginning, helped pull together the original group of about 8 of us who launched the Apache web server project as a fork of this original thing called the NCSA web server. I then shifted from writing code to being kind of sysadmin to the stars, because like a lot of you, I'm sure, like being close to the metal, being close to like the hardware that was being used to build this community, build the Apache community was really core. After a few years of us kind of working as an email list, kind of informally, we formed the Apache Software Foundation, which just yesterday celebrated its 20th anniversary of existing. And just to emphasize, it's not me, it's not one inventor, it was a community of people who pulled it together, which is now 3,000 different committers, 700 members of the ASF. I'm sure even some of you out here might be ASF members or have contributed in one way or another with an Apache project. And I just want to make sure all of you get recognized for the contributions you make to open source as well. And thank you for those of you who have. And that kind of history of pulling together communities of like-minded developers working for different companies on common infrastructural technology was something that didn't start with Apache. It even predated, I'd say, proprietary software in some ways. We had the internet before we had Microsoft long ago. But it's also something that is current and relevant in this world that we live in today. As you kind of heard me talk about a little bit, we live at a time when we are seeing things that we had kind of taken for granted as decentralized services getting kind of re-centralized under our feet. I'm sure most of you use Gmail, whereas most of you 10 years ago, I would guess, were running your own mail server, right? I still run my own mail server. I'm kind of a freak in that way. And that's centralization of email. Maybe that's trivial, maybe not. We'll find out when Gmail goes down one day. In general, though, there's other parts of the business world where that degree of centralization isn't something that's so lightly taken or people are happy with. And that's really driven us at the Linux Foundation to work on this thing called Hyperledger. And let me just dive in real quick, because a lot of you, I'm sure, rightfully are very skeptical of this word blockchain. This word has become simultaneously an overhyped buzzword and almost an anchor on the industry, a drag on the industry in some ways. But let me just take you back a little bit to kind of a definition of the word that hopefully helps just kind of drain some of the hype out of the system, drain some of the concern. For a lot of people working in the space now, the word blockchain, even if it started out life referring to a data structure of some sort or a particular way of converging on a consensus mechanism, in reality the term today encompasses two pretty broad technology domains. Distributed ledger technology, that way of forging a database where there is no master at the center, but essentially all of us are masters, being able to write to this ledger, where it's one written entry after another, sometimes building upon previous entries, sometimes enforcing certain physics like the prevention of double spend, being able to keep an asset from being spent twice to two different parties, two different nodes on the network. And then once you have that special kind of hybrid networked kind of database, being able to write smart contracts on top. Smart contracts being software that runs on every node in the network or some population of nodes in the network. And if those nodes independently come to the same answer upon running that smart contract, then a new entry is written to the ledger. This is a very generic way of describing these things. I apologize because there are so many different ways to actually converge on this. You've probably seen not just the Bitcoins and the Ethereums, but the hundreds of different tokens out there, the dozens of different network systems, that sort of thing. But all of them kind of converge on this similar model. And really it's about creating this immutable shared system of record and then using that as the basis to create this multi-party business workflow that is just architecturally very different than REST interfaces where there's always this power dynamic between the server and the client. And instead this is about a much more peer-to-peer way of building business networks. And the kinds of problems that you can solve with these things don't require all of us to be on one giant network at a time. They're the kinds of things that can get solved by communities of organizations binding together to build these different ledgers. And that's actually, in a way, a more decentralized way of thinking of this, and perhaps a more scalable way as well. And the three domains that we kind of see these needs emerging from first, and they're not really business sectors, they're more kind of categories of use cases, are in financial services, so obviously the moving of money from one party to another, but also things like KYC, AML, or securities of companies, or P2P lending, or trade finance, for example. In the supply chain space, which is very closely related, you see a need for provenance tracking. I'll give some examples coming up, but everything from diamonds to rice to rare earth metals to electronics. There's a need for a common system of record between parties in any supply chain on where did this given pallet or this given small package with a barcode on it or any sort of type of trackable kind of attribute to it, where did it come from, and how do we trust that it came from where it came from, right? How do we have things that harken back to the PGP Web of Trust model or back to any type of digital certificate kind of system? How do we actually get to a point where when somebody says, I received this pallet with this barcode and I put it on a truck and sent it on its way, how do we know that that is actually a valid history when we're all the way at the end of that cycle? This is technology to try to solve those kinds of problems. And then surprisingly in healthcare, there's all these multi-party communication and data management kinds of challenges that client-server technology just hasn't solved. I don't know what the situation is in Europe, but in the States, our healthcare information systems are broken. And it's because the client-server world has conferred this kind of aggregation and power status to the parties who own the data. They haven't really been interested in sharing that data. In a more decentralized way, we can get to patient record sharing and other things. This is the grand hope, right? This is what a lot of people are working on. Now, I didn't want to spend the majority of this time selling you all on blockchain technology and why it's the answers to everybody's problems. I'll talk about a few examples, but I just wanted to kind of paint a picture and then really talk about how we're using open source to fulfill that. And if you think of this stuff, I mean, you might have sat there going, but what about tokens? What about proof of work? What about all that energy consumption that's being used? Which, by the way, the amount of energy being used to mine Bitcoin these days is the same as the amount of installed solar capacity in the world. So all of the energy efficiency we've gotten from deploying solar panels is now being burned, essentially, to mine Bitcoin. That's not good. But in the broader sense of the blockchain world, there is this spectrum from the public permissionless wide open ledgers like on Bitcoin and Ethereum and the other public cryptocurrencies, all the way to, on the right-hand side, your permissioned, private, small, distributed ledgers. You could even think far off the screen on the right-hand side, you have central databases. Far off the left, you have uncoordinated kind of databases, right? But really, there's this window in between the cryptocurrencies and the central databases where there's a lot of interesting problems worth solving. Ones where you need that ability to decentralize, to verify, to know what was written, to have that immutable ledger, but you don't need to be able to burn all the CPU power, which is what you need on the left-hand side, to fight what are called Sybil attacks and that sort of thing. Happy to go more into that. But the dimensions really here to think about are these networks public or are they private? And are they permissioned, meaning there's somebody checking your badge at the door, just like we had here, or permissionless, where anybody can come in the door and engage. And these are the rough dimensions to think about in the blockchain space. Speaking back to the use cases, you've probably heard about some of the traceability work done out there by groups like Walmart, who are tracing now the flow of leafy green vegetables from suppliers to and shippers and processing plants out to their retail sectors. They are a part of a network that actually IBM has helped set up called the Food Trust Network, where they're an anchor participant, but it's other retailers and it's lots of different growers, and it's a marketplace ecosystem that now is in production and is now cutting the time to trace foodborne illness and other types of issues in the grocery supply chain in a huge way. In fact, Walmart is mandating that all of their tier 1 suppliers get on this network by the end of this year. A startup company called Circular, based in London, I believe, has implemented a distributed ledger tracing rare earth metals to make sure they come from properly regulated mines in Rwanda and not from mines that might employ slave labor or poor working conditions in the Congo. And that's tracing materials all the way to batteries that end up in your iPhone, which is pretty cool. And then ScanTrust, which has worked in rice, they've worked in coffee, they've worked in a lot of other commodities to do supply chain traceability. There's even an angle on this with digital identity, and I'll talk about that in a little bit, but the government of British Columbia has actually deployed a blockchain system, again, using part of Hyperledger's technology to provide digital identities for businesses in a self-sovereign identity approach. And those case studies and more are on the Hyperledger website. Again, I'm not going to hammer you with the why. I'm going to talk more about the what. But one thing that's also really interesting that we've seen is adoption of this technology now across all the major cloud providers. AWS, Google, IBM. IBM was really the first to deploy a commercial service in this space. Their blockchain cloud service now has over 100 different networks that have been spun up on it in production or late stage pilot. Really awesome to see. But now you can go to any one of these cloud providers, including all the major cloud providers in China, Baidu, Tencent, Ali, and Huawei, and procure blockchain as a service, essentially. Have them fire up these nodes, have them fire up a network. IBM and Microsoft actually showed at a conference a few weeks ago, provisioning independent nodes onto the same blockchain network from IBM's cloud service and from Azure, and those nodes now being able to be on a common distributed ledger. That's really cool, right? So we're getting this really broad footprint for this technology. But let me take a step back. What is Hyperledger in the first place? What is that word? And to really understand it, you need to understand a bit about who the Linux Foundation is. I mean, first off, we're an open source collaborative effort to advance cross-industry blockchain technologies. We're hosted at the Linux Foundation. I draw my paycheck from the Linux Foundation, as does my small staff of about 8. And we're a global collaboration of companies in finance, in banking, in IoT, in supply chains, in all these sorts of different fields, but also a lot of ISVs and a lot of infrastructure providers who realize there's a lot to build out in this space. The Linux Foundation, this is a crowd that likely, on average, knows more about who we are and what we do. We're kind of like the Apache Software Foundation in that what we're about is building projects that are these collaborations between anybody who wants to show up. but predominantly the people who show up are the companies and the developers working for those companies who are interested in solving some architectural issue, some infrastructural issue, writing software that is non-differentiating, but is necessary to accomplish some other higher level task, right? And the Linux Foundation exists to pull those resources together to provide just enough program management, air traffic control, kind of convening of the different participants, but not to write the software themselves. I don't have any software developers on my staff writing code for Hyperledger. What we do is manage the folks who do show up, make sure that any hour that is spent by a developer either learning how the code works or deciding to contribute is an hour well spent, is as efficient as it possibly could be. The Linux Foundation actually hosts over 150 different projects like Hyperledger. We're one of the larger ones and one of the more faster growing ones, but there's others you've likely heard of, such as the Cloud Native Compute Foundation, which is the home of the Kubernetes project and a bunch of related technology projects. The Node.js community, which actually just merged with the JavaScript Foundation, providing building blocks for web technology. All sorts of stuff in the automotive and telco space to just remake those industries through open source code, and now in the blockchain space. Actually, for the last 3 years, Hyperledger was founded at the end of 2015, actually, and the first code drop happened in February of 2016. So we've been going strong, and in that time, we've actually pulled together a set of technologies, something that we call the greenhouse, focused on a lot of different angles on how you build these distributed ledger and smart contract systems. It's kind of a nerd's paradise. Within Hyperledger, what we provide for this greenhouse of different technologies, and I'll walk through them soon, are some common tools, things like whether it's ensuring that they all have the same license, the same Apache version 2 license, the license that I think has come to be the standard license for building business software, open source software, to a common framework for making sure that the history of those code contributions is tracked, so code doesn't come in from, say, somebody who has a patent who's trying to sneak code in so that they can then exercise a patent right against parties who use that code later on. To an integrated set of tools, building, of course, on top of GitHub, but also providing alternatives like Gerrit and Jira and chat systems and obviously email, to then going out and being able to tell the world about who we are and what we're doing and help them understand how they can get involved. But all of this would be moot unless there was a team of developers. People who actually came together from different companies or just independently minded to work together on common code. And there we actually help enforce a set of rules that are very similar to the rules that you might have on an Apache project or any other well-run open source project, that they have to build the code in the open. That the developers are the ones who manage the roadmaps and release schedules. They're kind of in charge, but they have to do that transparently, and they have to take advantage of people who show up and say, I want to help, if I want to fix a bug or want to add a feature, how do I get channeled in, right? We do set a bunch of policies and requirements for these projects as they go from somebody who just shows up, gets accepted by a technical steering committee as a project at Hyperledger, and then advance from incubation status to active status to doing their first 1.0 production release. And then we try to beyond like a GitHub or even the ASF, who are kind of happy to take in any project that does anything, what we're trying to do is cultivate curate a portfolio of technologies that not just, have this blockchain concept in common, but actually help each other and relate to each other in some meaningful way. And then the Linux Foundation provides this kind of staff to be able to help manage this and all the different parts of this, from legal and marketing and events to community managers who sit there watching the developers, making sure that the conversations stay positive in the way that they should be, that the devs are using the tools in the right way. We find there's still a lot of developers who are new to open source development, and part of our job is to help bring everybody along and raise the floor on everyone's skills and how to work that way. broadly stated, we're not just here to do R&D and see what happens. We're here to build software that can end up being run in production environments. And this kind of software, when it's being used to trace assets in the real world, in some cases being used to track billions of dollars or more worth of financial instruments, security ends up being pretty important. Uptime and reliability end up being pretty important. And so every project at Hyperledger essentially gets put on a conveyor belt from good idea, an interesting skeleton of code, to production release. Our job here is to provide an infrastructure as well for this code to get written so that whatever happens, happens. We're not really a top-down kind of product strategy so much as a bottoms-up, where there's code people want to write, we want to be a home for that. And then we also realize there's a lot of education of the public that we have to do, a lot of advocacy, especially in this new domain where there's a lot of very healthy skepticism, a lot of overblown hype. I like to say, even though the first 4 letters of our name are HYPE, we've tried to be signal rather than noise out there and talking about where you might apply these technologies and getting tools into people's hand so they can actually build. So in the Hyperledger greenhouse, we have 12 different projects, and I'll walk through a few of the ones that are most interesting. But they're broadly divided between frameworks, tools that you would run at a node-by-node level to be able to build your blockchain application, and then other tools that are just more assistive, things like a performance tuning, performance measurement tool, a cloud management kind of tool, an IDE for building these kinds of apps, for building distributed apps, etc. The granddaddy of the projects, the one that kind of kicked it all off, is this thing called Hyperledger Fabric. And Fabric is really a general purpose platform that can be used to build any type of these blockchain applications, and has been used now in over 100 different production networks. Every one of IBM's networks that are live on their cloud, as well as what feels to me, just from anecdotal conversation with others, because it's really hard to get metrics in this space, at least half of the other production networks that get talked about out there. What's great is I have a Google alert on Hyperledger, as I'm sure you all do for your projects, and every day I'm seeing word of new projects coming out that people are building on top of Fabric and rolling into pilot or even production. One of the more recent ones was NASA, a research scientist, a group at NASA, building a prototype for the next generation air traffic control system on top of Fabric. And Fabric is pretty mature. A long-term support release called 1.4 was released in January. There'll be a few point releases on that for the next 18 months. But this is now, if you want one platform to build on that is the mature one, that's documented best, that's the one to go for. But a sister project to that, and one that's competitive in some ways, and which might be more appropriate for certain use cases, is Hyperledger Sawtooth. And the high-level metaphor that I give you to understand the difference between those two is they're kind of like the difference between Postgres and MongoDB, in that you can build a shopping cart app, or you could build most websites on either one of those, but as a developer, you know that they make different promises to you in terms of what they perform and how they work and that sort of thing. And so there's a different consensus mechanism used by Sawtooth, one that takes advantage of secure enclave work, and secure enclave systems that are in Intel's chips, for example. And it's potentially better for very large networks of hundreds to thousands of nodes. So it's somewhat more experimental, but it's seen a 1.1 release, and it is in production out there, and it's really worth checking out. A more special purpose type of framework tool is Hyperledger Indy. And Indy is used to implement what's called self-sovereign or user-centric digital identity. It might sound strange. We're talking about blockchains here that are immutable, that are very widely shared. Why would you use this for a digital identity system where personal information is very sensitive, and with a GDPR you want to be able to delete things? That seems kind of opposite, right? Well, the digital ID systems that we have today outside of the blockchain world all still fundamentally work like LDAP, right? They work by consulting some central server that somebody has an account profile on, and when you badge into a front door, that means somebody else at the signing authority is going to know that you did that, right? We need to move to a world where that is privacy first, where identity is more about things that you hold close to you in something like a wallet, rather than what's stored remote about you on a server somewhere. And being able to prove the integrity of these claims, being able to limit who you share these claims with, and being able to keep an audit trail of who you've shared this with and why, and being able to revoke that consent to be able to share that data. All those kinds of things require a much more decentralized approach to the issuance and verification of identity. This is the basis for Hyperledger Indy. It's being put into production this quarter by a network called the Sovereign Network. It's run by a nonprofit called the Sovereign Foundation, which you can kind of think of as like an ICANN for distributed digital identity. And think of this software as Bind, or DJB DNS or something like that. But this is software, and there's a lot of fun things in there, zero-knowledge proof systems, that sort of thing, to help preserve the integrity and the privacy of individuals whose data not is being stored by the system, but where you store hashes and keys and public keys and other things that help you prove the integrity of the documents that you're presenting. And it's really, this is the system where if we're going to get to digital passports, digital driver's licenses, digital diplomas, that sort of thing, it'll be through systems like this. Hopefully this will be one of the category leaders in that space. But in another related space, there's a lot of questions about, well, how would we relate to the different smart contract types of proposals out there, or networks out there, such as the Ethereum network. So putting aside the cryptocurrency token, the ETH token, one thing that's really cool about Ethereum has been the smart contract language that community came up with called Solidity, and a virtual machine for running those smart contract systems called the EVM. And it's an EVM, it's a smart contract engine that is aware of this fact that it's running in this very novel environment, which is distributed across every node in a blockchain, right? And so really it's careful about resource constraints and that sort of thing. And so at Hyperledger Burrow is an implementation of the Ethereum virtual machine. It runs standalone on its own consensus mechanism using something called Tendermint, but it can also now run on top of either Fabric or Sawtooth. And then just the fifth project I wanted to mention, Hyperledger Iroha. This is more of our wild card. This is a technology that came from a startup in Japan that was building portable digital payment systems and had kind of virtual currencies at anime conferences and that sort of thing. Now it's growing in some interesting ways. There's the National Bank of Cambodia is piloting this for their digital token system. There's a lot of other interesting projects going on here. It uses some more advanced Byzantine fault-tolerant consensus mechanisms and is really designed for kind of a mobile space. So again, differences that are hard to relate at a top level, and things that if we were an ordinary product organization, it would look a little nonsensical, but as an open source community, bottoms up, grassroots, it makes sense. And then we've added 2 more projects recently. We're still working on a graphic for one of those, but 2 that I think are really important to this space. One is Hyperledger Ursa, which is a library that it takes all of the cryptography, the hard mathematics involved in all the other projects, puts them into one common location, tries to standardize the interfaces to them, and make it easier for those to be verifiable, to be bulletproofed, right, for us to put up bug bounties against, and to also implement national encryption standards into in countries that specify those. And then Hyperledger Grid, which is a library building on top of Sawtooth that makes it really easy to build supply chain traceability applications. Those were 2 projects that came in just in the last few months. And the foundation for all of this is open source collaboration. The foundation for, I mean, I'm hoping 25 years into the open source revolution. Well, 20 since the term open source was devised, 25 since, you know, at least I started to get involved in open source. In some ways, even going back to the 1980s with the Free Software Foundation. I hope that this pattern of finding ways to pull parties together to work together on common code in a meritocratic, or actually the term I prefer is duocratic type of community, where people realize there's things that need to be fixed, there's features to add, and it's so much easier and more convenient to collaborate with others to solve those problems than to try to solve it on your own and then try to sell that, right? Certainly there's room for proprietary software in the world. Certainly the further up the stack you go, that tends to be better for proprietary software. But the key to making all this stuff work and be scalable and actually multi-vendor, vendor neutral, but multi-stakeholder is a term that I prefer, is to have a process that is public and transparent. And so that's really what we're trying to do at Hyperledger, and make sure that no one's confused about how to make open source actually work. And so we use all the tools that you would expect any healthy open source community to use, from an updated and modernized wiki to chat, rather than using Slack, by the way, because Slack is not really good for public communities. We use something called Rocket Chat, which is another open source chat system. I definitely recommend you guys check it out as a nice complement to GitHub and other tools like that. But this community also has a lot to learn from each other, and more than I've ever been comfortable with. I was never a big fan of phone calls, but what we've found is that pulling this community together, especially in a young space like this, has required having a lot of time on phone calls and engaging with each other even face to face. So we run each week probably 30 different phone calls for the different groups, different communities, to kind of engage and figure out, how do we move this forward? How do we build, something and ship it, but also work across different categories. We've also started to do something called boot camps, which are a way of getting out into a region and engage people who are just at the beginning of their learning curve, from being, perhaps not even users yet of the technology. Really, the focus is to make them contributors and hopefully core maintainers on these projects, because we need that more than just one heroic kind of person writing code and shipping it out. We need more than just one company supporting the development of any one of these projects. And so the only way to do this, we found, is first, make sure you're using the tools correctly, but secondly, get out there and engage with developers. We ran a very successful one at the beginning of this month in Hong Kong, and we're hoping to repeat that in India, in the US, in Europe, and in South America before the middle of this year. Because it's a great way for people to understand open source is about people. Another angle at this is we've, since the beginning, really engaged the Meetup tool as a way to bring local communities together. Sometimes they skew more business-like than developer-like, but as people have been trying to figure out what is enterprise blockchain at all, having local conversations has been essential to making that work. We also have now, this is our third year of running internships at Hyperledger. So we are funding $5,000 summer internships for students predominantly, but anybody can apply, across 15 different, actually it'll be 17 different projects with mentors attached to them, helping support the development of Hyperledger code. And even if no code ends up as a result, even if it's just better student developers and more engagement, that's still a big win for us. We've recently started to get into training and certification of devs. Now that we're 3 years in, now that these systems have kind of some settled mechanics as to how they work, now it's time to professionalize. Now it's time to help people understand that they can go out and recruit devs that list Fabric and Sawtooth and administrators on those in their background, and that it'll work. Lots of ways to engage. I'm cutting it short because I know my time here is limited. Lots of different working groups that cut across these projects. Lots of different special interest groups to go out and engage the business community on top of this code. These are all the tools. I'm sharing them with you because I want you to understand there's a lot more work left to do in the open source world. There's a lot more layers of technology that are evolving. We're a younger technology space than the web is, or even the cloud, which is now a good 8 or 10 years in. But building these layers and building the commercial ecosystem around them is essential to actually getting this stuff to be multi-vendor, multi-stakeholder, and getting it beyond just a few small technology providers, lest we end up back in the world like we had at the early days of Apache, where one company owned 95% of the desktop, and the presumption was that they would own 95% of the web. We helped keep that from happening, which is cool, But this is not a war that has an end. This is not a battle that has a conclusion. This is an ongoing process for us. And that's really what the Linux Foundation's about. In some ways, even that's what Hyperledger's about, is building these flatter, more collaborative commercial ecosystems and developer ecosystems. And so I get out there on the field a lot. This is me in Antarctica talking about blockchain to penguins and ice flows. When we have our events, when we are able to pull people together, that's really the best. And with that, I will end it. Thank you.